Welcome again to ICMR NIE's sessions on epidemiology for Odisha. I think Dr. Manikam briefed you about introduction to epidemiology. Following that session, I'm Dr. Archana, I'm a scientist at ICMR NIE. I will be discussing with you about measures of disease frequency, right? So at the end of this session, each of the participants we expect must be able to calculate incidence, prevalence, and some of the mortality measures. So many of you may be wondering why should we measure disease frequency? I'm sure Dr. Manikam has talked to you about the definition of epidemiology and what epidemiology is all about. Epidemiology is all about understanding how health-related events or diseases are distributed and what are the determinants. And by knowing these, how can we take public health action? So, epidemiology is concerned about understanding frequencies and patterns of health events or diseases. So, the main concern that most of us may be having is for any particular disease, let's say hypertension or diabetes, at any given point in time, how many people are in that particular state? How many have diabetes or how many have hypertension at any given time point? Another question that we might want to ask is, how likely is an individual to get diabetes or hypertension if he does not have it today over the course of next 5 years? So I think these important questions can be addressed only if you know how to measure health-related events or how to measure diseases. So that is all what we are going to discuss in this class. So the basic approach that any field epidemiologist takes is the mnemonic that we constantly use here at NIE and overall in all the field epidemiology trainings is CDC. So many of you may be knowing CDC as Centers for Disease Control in Atlanta, but for field epidemiology, CDC also means count, divide, and compare. So for any epidemiologist, it is important for us to count the number of individuals with the health-related event of interest. For example, if you are interested in identifying what is the prevalence of hypertension in a given population, first you will have to go and count the number of individuals who have hypertension, and then you have to divide that number by the total number of individuals who are likely to develop hypertension or who are at risk of hypertension. And then if you want to see how hypertension prevalence is in different districts in Odisha, then you have to compare those prevalence measures. So any field epidemiologist will investigate using these principles. First, he would count the number of cases divided by the population at risk of developing the disease, and then he would compare whatever rates he gets in different subgroups of interest. It could be men, women, it could be comparison in different districts, it could be comparison among diseased, non-diseased, etc. So, when we want to measure disease, you could either talk about total number of just the numerator, total number of individuals who have hypertension at any given time point, which is called as counts, or you have got measures where you divide one value by another. Those measures could either be ratios, proportions, or rates. So disease can be measured either as counts, ratios, proportions, and rates. So what is a ratio? A ratio is a measure which has got a numerator and a denominator, where the numerator need not necessarily be part of the denominator. What is the oft-cited example for ratio? Many of you may have heard about male-female ratio. So men and women are two different entities. So the numerator is not part of the denominator. When you have got measures where there is a division of a numerator and a denominator, but the numerator is not necessarily related to the denominator, then that sort of measures are called as ratio measures. So what are the examples for ratio measures? One example I told you is the sex ratio, male-females. Another example could be the number of doctors per beds available in a hospital or beds available in a district. Another example could be population density, number of people with the square kilometer area. So there could be several examples for ratio measures. So when you're trying to measure diseases, sometimes, or when you're trying to measure health-related events, sometimes you may be using these measures. Another important measure of disease frequency is proportion. So mathematically, when we call something as a proportion, it has got a numerator and a denominator, where the numerator is part of the denominator. So numerator must be included in the denominator. So for example, if I say out of the 100 individuals who have come who are more than 30 years to my PHC today, after screening, I found 15 of them to have hypertension. So total 100 people came, of them 15 were detected to have hypertension. So then that is a proportion, because the 15 is the numerator. Those individuals are part of the 100 individuals who totally came to my PHC for screening for hypertension. So in proportion, the numerator is always a part of the denominator. Now another measure which I told you is rates. Now, I'm not going to discuss rates right now, but rate is a special form of proportion where there is a dimension of time in the calculation. So later on in my slides, we will be looking at a rate, and at that time point, I'll be discussing about rates, not now. So till now, what we have seen is, why is it important to measure disease? In order to measure disease, what do we use in epidemiology? In epidemiology, our principle for measuring diseases is counting the health-related events of interest or diseases, dividing them by those at risk of developing that health-related event or disease, and then comparing it for the purpose of understanding where public health action is needed or to understand causal relations. I think till this point, we have covered rates, ratios, and proportions. Rates we will be covering slightly later. So the key topics for today's class is to understand what is prevalence, what is incidence, what is relation between prevalence and incidence, and also a little bit about how to measure death or how to measure mortality. So that covers the introduction aspect of my session. Let's go to the topic proper. So before understanding how to measure prevalence, incidence, and measures of mortality, let's look at what epidemiologists mean by population. When epidemiologists talk about population, they are talking about a group of individuals with similar features or group of individuals with similar characteristics. And it is about this group of individuals that I want to make some conclusion about. For example, what is the prevalence of hypertension among individuals who are in Chennai? So the target population is individuals who are residing in Chennai. So it could be either geographic, or it could be all women, it could be gender, or it could be any demographic characteristic that you use to define population. So population at risk is that portion of the population that is susceptible to get the disease in question or the health-related event. Now, what do I mean by susceptible to get the disease or health-related event? Let's take the example. Suppose if you want to look at carcinoma of the cervix incidence. So the population at risk of developing carcinoma cervix includes only women, does not include men, and maybe only in the age group of more than 20 to less than 70 years, because this is the age group in which carcinoma cervix is most likely to happen. So the population at risk of developing carcinoma cervix means it is limited to that portion of the population which is susceptible to get cervical cancer. Of course, men are not susceptible. Very young individuals are not susceptible to get CA cervix. Similarly, if we want to talk about what is the susceptible population at risk of developing hepatitis B, then these are the individuals who are negative for core total antigen for hepatitis and also who are negative for anti-HBs. So similarly, for diseases of interest to you, you can identify who are the individuals who are likely to get the disease, who are susceptible for the disease. Having understood that, I've got a small question for you. I hope that you would give me responses in the chat box, or you would unmute yourselves and give your response. My question is, I have given you a graph, a bar chart to you, which is talking about city A, city B, and city C's number of cases, number of new cases of asthma. And I want you to tell me, which city do you think has got the largest risk of asthma? Whether it is city A, B, or C.
City A.
City A.
City A.
Any other responses that we are getting in the chat box? Hari, can we see the chat box? Is there any other response? So some of you have responded as city A. Now,
City B is less. City A is more.
City, okay. So many of you are responding city A because city A has got 100 number of new cases of asthma. Now, what if I say that city A is a large city like that of Chennai, whereas city B with 50 new cases of asthma is a small city like that of Pondicherry. Now, Chennai, the population is approximately 80 lakhs to 1 crore. And Pondicherry, the population is approximately 10 to 15 lakhs. So 50 cases in 10 to 15 lakhs, does it offer a higher incidence or 100 cases in a population of 1 crore? What do you feel?
City offers.
Yeah.
Depends on the population size also.
Yes. So the bottom line first take home message for all of you is, as epidemiologists, whenever we see only counts or whenever we see only numerator, that is number of cases, we cannot make much sense of it in terms of burden or in terms of how quickly the disease develops before looking at the denominator, which is the population at risk. So whenever next time anybody asks a question like you with a graph like this, you must say, what is the denominator? What is the total population that is at risk in city A, B, and C? Without knowing that, we cannot really say which city has the largest risk of asthma. So very good. That is the first take-home point for today's session. So with that take-home point, let's go to the first topic to be covered, which is prevalence. So what is prevalence? Suppose if I'm doing a cross-sectional study and I'm trying to assess the prevalence of hypertension, let's say in the area in and around National Institute of Epidemiology in Chennai, which is called Ayapakkam. So how will I go about doing the study? I will first identify a needed sample size, and then I will devise a mechanism to identify those individuals through a sampling technique, and then I'll go and measure the blood pressure using standard methods and try to identify what proportion of individuals who were part of my sample had elevated blood pressure. So that elevation in blood pressure, they could have had it for the last 10 years, or they could have been a newly diagnosed case of hypertension. So whenever you talk about prevalence, we are talking about at a given time point, how many individuals have the condition, irrespective of whether it is a new case or an old case. So the numerator for prevalence is total number of existing cases in a defined population at a specified point in time. So prevalence, the formula is at any given point in time, how many individuals have a disease, let's say hypertension, divided by the total population at risk at that specified time. So everybody, adult population is at risk for hypertension. So in some studies, we consider the total adult population as an approximation if exact data about population at risk is not available. So the take-home message from this slide is, whenever we are talking about prevalence, we are talking about number of observed cases or existing cases at a given time point. Now, it does not matter to us whether that case has been in existence for the last 5 years or whether that is a newly diagnosed case as on that date. Both old and new cases will be in the numerator because prevalence tries to look at burden of disease at any given time point. So that means total number of deceased, whether they are old or new, does not matter. So point prevalence. Point prevalence is nothing but measuring existing disease at a given time point in time. So this applies to data when it is collected. Let's say if we want to collect in January 2020, what is the prevalence of hypertension in 2020 as compared to hypertension prevalence in 2015, like that. So the formula is C divided by N, where C is the number of observed cases in time T, N is the population size at time T. So I'm going to give you a task. There are about 150 children in a school, and you're trying to screen for refractory errors at any given time point T. You identify that 15 children require glasses. So calculate the prevalence of refractory errors and please give me your answer. Hari, how do we see the chat box? Please type your answers in the chat box, or you can unmute yourselves and give the answer.
Madam 10.
Okay. We have got one response, 10 from Dr. Yadav.
Madam,
Yeah, 10. Excellent. So many of you are getting the answer. So how did you calculate? The numerator is total number of children who required glasses, that is 15. Denominator is the total number of children for whom screening was done. So 10%. Excellent. Excellent. We can close the chat box. Excellent. So I think point prevalence is very clear. Now we move to another concept which is called as period prevalence. No, period prevalence is not an often used measure in epidemiology, but in some cases you may be using period prevalence. Now, period prevalence measures frequency of disease over time. So for calculating period prevalence, I'm sure Dr. Manikam has talked to you a little bit about study designs, and I'm sure there are further classes where they will talk to you about more study designs. But period prevalence cannot be arrived at from a cross-sectional study. For period prevalence, you need to have follow-up data. So this applies when you have got data collected over a period of time. So this is called as period prevalence. So what is the formula? Period prevalence is C plus I divided by N, where C is nothing but the prevalent cases at the beginning of the time period, and I is the incident cases that will newly develop. So for example, I want to know what is the period prevalence of what is the 2-year period prevalence of hypertension in the area in and around NIE? What should I do? First, I should do a baseline survey. In the baseline survey, I will pick up the existing cases which will form my prevalent cases. Then over the course of the next 2 years, how many people are newly developing hypertension, which are called as incident cases during the period of 2 years? That will also go in my numerator. So prevalent cases at the beginning of my time period, that is in 2021, how many cases were prevalent in the area in and around NIE? And then over the period of next 2 years, how many are newly going to develop hypertension divided by the size of population in Ayapakam area. So this is how you calculate period prevalence. So period prevalence cannot be calculated in cross-sectional studies. You require follow-up data for this. So let me give you another exercise, just like that. Kindly calculate for this scenario. There is a population of 150 persons. I am following up this population for a period of 1 year. To begin with, my initial survey found out that 25 individuals had a disease of interest to me. Over the course of next 1 year, another 15 new cases developed for the same disease. Please calculate point prevalence first and then write in the chat box, and then you can calculate period prevalence. So first write point prevalence, then period prevalence. Chat box, please. Are you getting my point? For point prevalence, what is the formula? So we are getting some responses, 25%, 60%. Any other responses? So for those who have calculated point prevalence, can you calculate period prevalence and tell us? Let's go one by one. How will you calculate point prevalence? Point prevalence, the formula is the total number of people who have had the disease of interest whenever you're going for a survey. At that given time point, how many people have the disease? So what is the numerator? 25. What is the denominator? 150, right? So what is the answer for this?
26.6.
So 25 divided by 150, the answer is 17%. Yes, somebody has calculated correctly, 16.6% or almost 17%. What is the period prevalence formula? To begin with, in the initial survey, we found out that there were 25 prevalent cases of disease. Over the course of next 1 year, 15 people newly developed the disease, which became incident cases. So for period prevalence, what should be the numerator? The numerator should be 25, which is prevalent cases at the beginning survey, that is the baseline survey, and 15 new cases that have developed. 25 plus 15 divided by 150, so that is 27%. So period prevalence is 27%, point prevalence is 17%. So we will be sharing the slides with you, G. Do not worry. Yeah, you can close the chat box. So I hope that this is clear. Though we have got two measures called as point prevalence and period prevalence, most often or more likely you are going to use only point prevalence. Just what Goddess epidemiology also says, practically speaking, it is impossible to survey an entire city in a single day. Though conceptually we are thinking in terms of a single point in time, in reality, a survey to cover 500 people may take much longer. So whenever we are seeing the word prevalence without any modifier, It generally refers to point prevalence. So for all practical purposes, whenever any journal article or any scientific writing writes prevalence without any modifier, they are talking about point prevalence, which is the most common type of prevalence that is used in studies. Of course, there are some specific places where they may use period prevalence when they have follow-up data, but that usually you will not encounter more often. So whenever somebody says prevalence, they are talking about point prevalence or burden of disease at a given time point. Another thing that you need to note is prevalence answers the question of, at any given time point, what proportion of the population has the disease and what proportion of the population does not have the disease. So, but if you want to know when the disease developed, or if you want to know how likely a person who is without disease today will develop disease at a later time point, then prevalence cannot help you for that. So if you want to answer the question, how likely is a person to develop a disease over a period of time, then you are asking question about what is the risk of development of disease. And to answer the question of risk, you need to have data about incidence or you need to have follow-up data. So prevalence can give you burden of disease at any given time point. Whereas if you want to know the risk of development of disease, then you need to follow up the individual over a period of time and see how many individuals develop the disease and calculate the risk, which is otherwise called as cumulative incidence. So to close prevalence, the uses of prevalence data is, it is useful for assessing what are the healthcare needs. So in my particular area, 33% of the adult population has hypertension, 8% has got diabetes, so many people have got other conditions. So in order to assess what is the need of the community, estimate burden of the disease so that you can plan for health services. If suppose in your region the hypertension prevalence is only 4 to 5% or maybe only less than 10%, then maybe you will have to focus your resources towards other highly prevalent conditions. So planning and also in studying chronic diseases. These are the various scenarios where you will be using prevalence data. The next topic is incidence, wherein first we will be talking about what is the likelihood that an individual who does not have disease will develop disease over the next few years. That is what is incidence. So in incidence, whenever you are talking about incidence, it is talking about new cases that are developing in a specified population. So it could be for how many new cases of hypertension occur in a period of 5 years in obese individuals. So if I take 100 obese individuals who are not having hypertension as of 2021, how many of them are going to develop hypertension in the next 2 years or in the next 5 years? So whenever you talk about incidence, you must tell incidence for what period of time. Whether we are talking about 5-year incidence of hypertension or whether we are talking about 2-year incidence of, let's say, diabetes, or whether we are talking about 6-month survival of a cancer patient, etc. So incidence or any measure of risk tries to talk about how rapidly new cases are developing. How much are individuals who are non-diseased today likely to develop disease in the future? So there are several measures of incidence. One is called as cumulative incidence, which is the one that is most commonly used, otherwise called as incidence risk. Another is called as incidence density, otherwise called as incidence rate. So these two measures we will be discussing in the subsequent slides. So what is cumulative incidence? Cumulative incidence, the formula is number of new cases that have developed over a defined time period for a particular disease or a health-related event divided by total population at risk at the beginning of that time period. So the other names for cumulative incidence are, in the case of like infectious diseases, when you go for outbreak investigation, some people call cumulative incidence also as attack rate. So cumulative incidence assumes that the entire population at risk at the beginning was followed up for the total period of observation. That means, suppose if I want to identify 2-year cumulative incidence of hypertension, then my assumption is all the individuals who did not have hypertension to begin with, who were part of my study, would be followed up for a period of 2 years to see how many individuals developed hypertension. So Given that background, can you calculate the 10-month cumulative incidence of hepatitis C among injection drug users? So I have got here 4 individuals who are all injection drug users, A, B, C, and D. The blue color zone indicates the healthy period for that particular individual. The red color zone indicates the diseased period. The black color X mark indicates death. So given this, can you calculate the 10-month cumulative incidence of hepatitis C among injection drug users? So the numerator is the number of new cases, denominator is population at risk to begin with. Can we have some quick responses over the mic or in the chat box? Could you quickly tell me what will be the cumulative incidence of hepatitis C for a period of 10 months? Here we have got on the y-axis 10 months, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? For 4 individuals, A, B, and C, and D. There are no responses. Anyone wants to respond on the mic? 2 by 4, okay, 1 response. Any other response? So while others are thinking about response, let's discuss the answer. Chat box is closed. Yeah, please close the chat. So the catch in this question is, anyone who has got disease to begin with, like look at the person B. Person B, to begin with during our study period, he already has disease. So he is not at risk at the beginning of the study. So how many individuals are at risk at the beginning of the study? A is at risk, C is at risk, and D is at risk. So denominator, population at risk at the beginning of the study is 3. Numerator is how many people developed the disease during the study period. So C has developed the disease at approximately 3.5 months. D has developed the disease at approximately 2.5 months. So numerator is 2, denominator is 3. I appreciate the person who wrote 2 by 4. He has included everybody in the denominator, but the catch here is B is disease to begin with. So he, at the beginning of the study itself, is not at risk of the study, so cannot be part of the denominator, right? So B begins the period already diseased, therefore is not at risk of developing the disease. So incidence risk over 10-month period is 2 by 3 or 0.67. So risk is nothing but probability that an individual will experience a change in the health status. Here change means going from non-disease to disease, going from not having an health-related event to having an health-related event over a specified follow-up period. So this assumes that the person to begin with does not have the disease and also does not die from other causes apart from the condition of interest during the follow-up. So the other term for risk is cumulative incidence. So the layman term, when we say risk, we are talking about cumulative incidence, otherwise known as incidence risk. However, in real life scenarios, whenever you have got patients in follow-up in your care or whenever you are doing a study, look at this scenario. This is a study of 4-year period. Subject 1 is entering the study, let's say at approximately 6 months, and is there throughout the study period. However, subject 2 enters at the beginning of the study itself, but at the end of 3rd year, he moves out to another state and he is lost to follow-up. Subject 3 is coming after 1 year and then he is developing disease. So in real life situations, when you have patients under your follow-up care or when you do studies where there is follow-up involved, individuals may enter into the study or may come to your care at any given time and may exit for various reasons. So they may exit for out-migration, or they may get a job somewhere else, or they may just simply not come to your center for care. So in real life situations, people cannot complete the follow-up period, especially the study period. So there will be bound to be lost to follow-up. So all the study subjects or all patients under your care, whoever were there in the beginning of the period of interest, may not continue to be there till the end of the period. So all of the study individuals are not at risk of developing outcome throughout the study period. So they are at risk of outcome only during the time in which you have follow-up data. So now you can understand that cumulative risk cannot be calculated in such situations. The better measure is what is called as incidence density, which is otherwise called as incidence rate. So the formula of incidence density is, the numerator is the same, number of new cases within a defined period. However, the denominator is total person time of observation. This is otherwise known as incidence rate, and this reflects exactly how much person time the person has spent in your study or person has spent in your care. So how do you calculate this denominator, which is nothing but person time of observation? Now again, this is a hypothetical example. We have got 5 individuals enrolled in this study, hashtag 1, 2, 3, 4, 5. On the x-axis, we have got years, 1, 2, 3, 4, 5. So it is a 5-year study and I have enrolled 5 individuals. Look at individual 1. He is there from the beginning throughout the end. So the number of years of follow-up that person 1 is contributing is 5 years. The number of years of follow-up person 2 is contributing is only 1 year. 3 is contributing 2 years. Similarly, 4, 5 years and 5, 4 years. So if you want to calculate the total person time of observation in our study, then you will have to add up all this, which accounts for a total of 17 person years of observation. So in this case, suppose if you are looking at an event which is marked as X, if you are going to do incidence risk, then what will you do? 3 divided by 5. Whereas if you want to do incidence rate or incidence density, then it should be 3 divided by 17 person years of observation. So that is the difference between incidence risk and incidence rate. So for example, in this scenario, each box represents 1 year period. Red color represents development of illness and dot represents loss to follow-up or censoring for various reasons. So total follow-up in this case is 41 person years of follow-up and number of individuals who have developed the disease of interest is 2. So can anyone quickly calculate what is the incidence density? Can you just unmute and tell what will be the numerator, what is the denominator? So for calculation of incidence density, numerator is what? Number of new cases that have developed during the follow-up among the persons of risk. Denominator is total person time of follow-up. Here the total person time of follow-up is 41 person years. So 2 divided by 41 is incidence density, and if you multiply that and calculate for 100 person years, you will get 4.9 per 100 person years. So 2 divided by 41 into 100. That will come as 4.9 for 100 person years of follow-up, right? So this is how you calculate incidence density. This is specifically useful when you have got a lot of loss to follow-up and when you have got real-time data along with period of observation. So how do you understand or make sense about person years of follow-up? I think somebody has correctly calculated also. Very good. So when I say 1,000 person years of follow-up, it could be that I have followed up 1,000 individuals for a period of 1 year. Or it could be that I have followed up 500 individuals, each individual for 2 years. Or it could be 250 persons followed for 4 years. And so there are multiple permutations and combinations. So here, each person, if he's followed up for 1 year, he's contributing to 1 person year of follow-up. That should be the basic baseline understanding. So when do you use incidence data really? Incidence often is used when you have got follow-up data and you want to look at trend in diseases. Suppose you have got a high incidence of, let's say, cervical cancer. You are introducing a cancer screening followed by colposcopy and treatment program, whether the incidence of cervical cancer has decreased in your area. Similarly for malaria, similarly for other diseases. So in order to describe trend over time and see if your primary prevention programs are leading to reduce in incidence or decrease in incidence, then that is where you are going to use incidence data. So next, now that we know how to calculate prevalence and incidence, what is the relationship between incidence and prevalence? So for this, suppose I have got a population of interest which is represented by the flask. At a given time point, I'm doing a survey and all the individuals who are having the disease are represented by the blue beads. So my baseline prevalence is that black color line. Over a period of time, now more individuals develop the condition. So when new cases keep on adding, then your flask gets more full. So at another time point, you see that there is an increased prevalence because new cases have increased over time. Now, in a different scenario, what could happen is the individuals who were initially having disease at A might have died or may get cured of disease. Like for example, in hepatitis C, you now have a cure. So in that case, what will happen if the diseased individuals get cured or they die and they leave the population, then there could be a decreased prevalence at any given time point. So intuitively, you can understand that prevalence at any time and over time can keep changing if new cases are getting added, or if the cases are getting cured or dying, or if your numerator or denominator is changing. So in short, prevalence depends upon incidence, duration of the disease. So you can simply say the simplified calculation is prevalence equal to incidence into duration of disease. So when you see change in prevalence from one time point to another time point, that could be because of changes in incidence, changes in the duration of disease. Maybe there is a new cure which has been developed, or maybe individuals are dying more of the disease, or there could be other cases. What if your denominator is changing? Suppose your population at risk because of some flood or something, a lot of individuals have out-migrated from that area. So your denominator has reduced. In that case, there could be change in prevalence. Or suddenly there is an economic boom in your region and new people are migrating from other states to your state. In that case, the denominator is increasing. So prevalence over time can change for various reasons. You have to understand which reason is contributing to change in prevalence, whether the incidence has gone up, whether the duration of disease has altered because of a cure, or because of some other comorbidity which is prolonging the disease, or is it that the denominator has changed, whether there is out-migration or in-migration of people. So what could be the potential causes of increase in prevalence? It could be a low cure rate, a low case fatality rate, or it could be suddenly increase in new cases over time. Like for example, as there is an increase in obesity, there is an increase in diabetes, there is an increase in hypertension, increase in cancer. Or there could be immigration of patients from other places. For example, if you have got a new tertiary care center which is providing very good care, a lot of patients from other neighboring districts come to your district. That could lead to an increase in prevalence. Or you are having a new active surveillance which is improving the detection, or you could have denominator getting reduced, like immigration of all the healthy people. Similarly, if you observe a decrease in prevalence of the disease over time, that could be because you have developed a very good cure for a condition, or it could be because new cases are not coming to that extent, your primary care prevention is working, or cases are moving from your district to a neighboring district where a new AIMS has come or something like that. And so the basic conclusion here is, over time, if suppose you do a study in 2015 and today and maybe in 2020, if you see a difference in prevalence or a change in prevalence over time, there could be multiple factors that are causing that changes in prevalence. Before making any conclusions, you will have to assess whether any of these things have happened, whether anything has led to a change in the numerator and the denominator. So till now what we have covered is we have covered measures of disease. We have talked about what is the burden of disease at any given time point measured using prevalence. We have then talked about how likely an individual is to develop disease over a 2-year frame or a 5-year frame, which is risk of disease or cumulative incidence. We've also talked about incidence in terms of incidence rate or incidence density, wherein you have got number of new cases divided by person years of observation. So I think measuring disease, I think now all of you are comfortable about. Quickly, before I conclude, I want to talk to you about how do you measure death. So one of the common measures, which is also a crude measure of population health, is crude mortality rate. So what is crude mortality rate? In the total population, how many deaths are happening for a period of 1 year or for a specified period. So crude mortality rate talks about number of deaths in a specified period divided by the average population. So this does not take into account factors like what could be the gender relation with death, or what could be various strata like socioeconomic strata, etc. It just talks about an overall status of population health. Like for example, if you compare the crude mortality rate of India with that of a Western country or with that of a sub-Saharan African country, you could make some changes. Like the crude mortality rate of US is much lower than that of India. Maybe in the sub-Saharan African region, it's much higher than that of India. So it provides a gross information about population's health status. Another measure of how do you measure death is disease-specific mortality rate. So out of the total population at any given time point, what is the number of deaths from a specific disease? Let's say, how many individuals died from cardiovascular disease during a specified period divided by total population at risk. So that gives you disease-specific mortality rate. So this gives you an indication of how much is the burden of disease on the population. For example, you know that much of the deaths in India, roughly about 50% to 60%, is all because of non-communicable diseases. So what we are currently saying, non-communicable diseases are causing a larger fraction of deaths as compared to other causes of death. So burden of disease can be reflected upon when we are talking about disease-specific mortality rates. And you should not confuse this with case fatality. Now, what does case fatality talk to you about? Case fatality does not give you an idea of how much the disease is a burden to the population. Whereas case fatality talks about what is the severity of disease. Suppose if 100 people have developed the disease, how many of them are dying because of that disease? That is what is case fatality. So case fatality, unlike the measures like crude mortality or disease-specific mortality, case fatality reflects severity of the disease. So case fatality, usually whatever we commonly express, we express it as a proportion. Also, it can be expressed as a ratio. So what is case fatality proportion? If I have got details of all the individuals who have developed that particular disease in question, then I put that in the denominator, total number of cases who have developed the disease. I follow them over a period of time and see how many of them died from that disease and put that number in the numerator. So number of deaths among the cases identified, that is case fatality proportion. So you can calculate case fatality proportion whenever you have got follow-up information about all individual case patients. So here the numerator is a part of the denominator, and therefore this is called as case fatality proportion, which is what you commonly call as case fatality rate. So that case fatality rate is a misnomer. It is actually a proportion. In other situations, when you do not really have follow-up data, you can calculate case fatality ratio. For example, of the reported cases from the disease, how many have died because of the disease during a specific period? Now, this is used in surveillance data when we really do not have individual follow-up of each patient. Similarly, this case fatality ratio is now being widely used for COVID because we do not have individual line list and follow-up data of each individual at a national level, but we do have total number of reported deaths and total number of reported cases. So in surveillance settings, we use case fatality ratio. If you have got individual follow-up data, you can calculate case fatality proportion. Whatever you calculate, case fatality always helps you to look at how severe is the disease. For example, a disease like Ebola, the case fatality rate is very high. Whereas another disease like H1N1, the case fatality is not so high. So the take-home messages for today's session is, we have talked to you about how do you measure disease in terms of prevalence, which is a static measure and can tell you about burden of disease at a given time point. We then spoke about incidence, which is a dynamic measure which takes place over a period of time. If you are calculating risk, then you are trying to identify how likely is an individual to develop the disease. If you are calculating rate, how fast is the disease happening over time? And then we also spoke or touched upon certain measures of how to measure disease death, that is mortality, in terms of crude mortality, disease-specific mortality, and we also talked about case fatality. So with that, I think I conclude my lecture. I thank you all for the opportunity.